This may be a situation that you're familiar with, where you find an Android app that you want to install, but then you learn that it isn't available in the Google Play Store at all. But the website or the video that you're watching tells you that it's safe. So you tap download, and instantly your phone throws up a warning message about security limits. For many folks who are new to Android, that's going to be enough to make people think that they need to tap cancel in order to keep their device safe. So today, I wanted to focus on exactly what's going on here. We're going to take a moment to discuss the term itself, sideloading, and I wanted to go over some details that you should be aware of, so you know when to be worried about manually sideloading these files and when you can feel safe. Today, we are talking about sideloading APK files onto your Android smartphone or tablet. The word sideload is actually just a technical term for installing an Android application from outside of the official store. Unlike other rigid, walled-off smartphone ecosystems that dictate exactly what software you are allowed to run, Android was built from the ground up to give you the freedom of choice. Now, sadly, that freedom can come with a lot of anxiety, especially for those who are new to the Android ecosystem, or those who just may not be as tech-savvy as others. I see a lot of people asking that if you bypass the Google Play Store to install an APK file, are you going to be ruining your phone? Are you going to be handing over your data to a hacker? And the short answer to that is probably not. But there is a lot to understand here. So let's take a look at what actually happens under the hood when you install an unknown app from outside of the Google Play Store. First off, let's clear up a major misconception. Sideloading is a completely native, built-in feature of the Android operating system. You don't need to root your device. You don't need to run complex terminal commands, and you definitely don't need to be a hacker to do it. It's just an alternative pathway to installing Android apps onto your smartphone or tablet. When you download an APK file from your web browser and tap on it to open it up, Android intentionally pauses that process. And this is where you see that second security pop-up telling you that your phone is not allowed to install unknown apps from this specific source. See, in the older days of Android, there was just a single master switch hidden deep in your settings called unknown sources. And if you flipped it on, your phone would basically allow anything to install from anywhere. And honestly, that was a pretty big security risk. But modern Android is much smarter. Instead of that master switch for your entire device, Android now uses a strict, localized permission model for individual applications. The operating system is explicitly asking you, do you trust this specific web browser or this specific file manager to install the file? Because when you tap on settings and then flip that switch for your browser, you are only giving that one specific app the authority to hand off a file to the installer. You aren't allowing your entire phone to have that ability, like we saw with the previous iteration in Android. So, once you grant that localized permission, the standard Android installer takes over. You tap on install, the process finishes normally. It really is that simple. But knowing how to install the file is only half the battle, because the real question here, and the thing that causes the most anxiety, is how does your phone know if that file is actually safe? Especially if you're trying to install an update to an application that you already have, like Gmail or Google Wallet, for example. I've seen so many folks over the year asking if sideloading an update to Gmail will corrupt their existing data, and that just isn't the case. So let's talk about why. Every single Android application has something built into it called an app signing key. I know it does sound incredibly technical, but it's actually a very simple concept to understand. Think of this key like an unforgeable, highly secure wax seal. When a developer, let's use Google in this example, when they create an APK file for the Gmail app, they use their own strictly guarded private key to stamp that seal onto the final APK file before anyone is allowed to download it. And the core rule of Android security is that an app's signing key can never change during its entire lifespan. So, when you download an update for Gmail from a third-party website and then tap install, the Android operating system doesn't just blindly overwrite your files. It stops and it performs a strict background check. The system extracts the digital signature from the APK file that you just downloaded, and it mathematically compares it to the signature of the Gmail app sitting on your phone. If you downloaded a legitimate, untouched copy of the update, those two cryptographic seals will match perfectly. Because the math checks out, Android recognizes it as the exact same app, just a newer version of it. And that allows the operating system to safely replace the old version, keeping all of your logged in accounts, emails, and local data completely intact. And I completely understand. You may still be asking yourself, what if it's a bad file? What if some bad actor took the Gmail app, injected some malicious code to steal your passwords, and then put it up on some shady forum for you to download? Again, that won't be possible. Since the hacker doesn't work for Google, they don't have Google's secret wax seal. So, in order for them to package up that tampered file, they are going to be forced to sign it with their own entirely different key. In the exact moment you try to install that tampered file over your real app, the Android package manager instantly detects the mismatch. Because the seals are different, the operating system forcefully halts the installation process. It's going to throw up a definitive app not installed error and completely block the malicious software from touching your real app or your private data. And this is the most important concept to grasp when we talk about sideloading safety. While the Android operating system allows you to install files from anywhere, it fundamentally does not trust the website that you download that file from, and it exclusively trusts the cryptographic math embedded inside of the file itself. So now that you know if downloading and sideloading APK files are safe, meaning if you're updating an app that you have already installed, then the answer is a resounding yes. Android's app signing keys make it mathematically impossible for a hacker to sneak in a tampered update onto your phone without the system catching it. Your data is going to be safe, your accounts are going to remain secure, and you don't need to fear the quote, unknown apps prompt when grabbing an update from a trusted repository. But what if you have downloaded a brand new application, an app that you have never installed on your phone before? Because there's no existing wax seal on your device to compare it to, how does Android know that this completely new file isn't hiding any malware? And this is exactly what Google Play Protect was created for. And it's why the service is automatically enabled on your device from the factory. It acts as your phone's silent bodyguard, basically an antivirus, scanning new apps in the background in real time, even if you didn't get them from the Google Play Store. Now, I'm going to be doing a deep dive into exactly how Play Protect works and how it catches malicious apps before they can do any damage. So be sure you are subscribed to the channel so you know exactly when that gets uploaded. And I'll be sure to add that to the video description below, as well as the pinned comment here, so that it's easy for everyone to find. And if this video has helped clear up some of the confusion around sideloading, then please hit that like button so that YouTube knows it's really useful, and I'll see you in the next video.